In this section, we'll look at the Ionic CLI, or Command Line Interface. It's a tool that makes it easier to create a new Ionic project, build it, run it, and so on. To use the Ionic CLI, we first need to install it, of course. And we can install it globally on our machine by opening a terminal and running npm install -g, which means install it globally, and the package is called @ionic/CLI. Let's wait a minute or so for npm to download everything. Once the package is installed, we can verify that it's available by running ionic -v, which should just print the version number. We can also type ionic --help to show some documentation on how we can use this tool. Under usage, you can see that we can type ionic and then a command, where the command can be one of those in the list below. For example, the start command can be used to create a new project. If we want more details about that specific command, we can type ionic start --help, and this will print an explanation of what this command does, then show the usage instructions and all the possible options we can pass. Let's look at the usage in more detail. We can type ionic start and then pass a name, a template, and possibly some options. The name is obviously enough the name we want to give to our new project. As for the template, we can pass blank, which creates a mostly blank project, or tabs, that creates a project using a tabbed interface, or any of the other templates we can see by passing the --list option. We can start with a blank template. That's the simplest one. Now let's look at some of the options listed below. An important one is --type. You can use Ionic with different web frameworks, not just React, but also, for example, Angular. So we'll want to set the type to React in our case. There's also an option to enable capacitor integration. If we want to build our app for Android and iOS with capacitor, then we can simply pass this --capacitor option when creating the project. And you can look at all the other options yourself if you like. There are also some examples at the bottom. Now let's go and create a new Ionic project then. First, I'm going to change directory to my projects folder, which is where I keep all my projects. You can use whatever folder you want on your machine, of course. Now we can type ionic start. Let's pass my app as the project name. Then we need a template, and we can use the blank one. Next, we want to set the type to React. And finally, we could enable capacitor as well. Let's run this command, which might take a couple of minutes. Before completing, it's asking us if we want to create a free Ionic account, which gives you access to the Ionic forum and stuff like that. You can do that if you like. I already have an account, so I'm just going to answer no here. And with this, our new project should have been created. If we list the files in this folder, you can see that there's now a new folder called My App, which is, of course, the project name we passed to Ionic Start. So let's go into that folder and open its contents in Visual Studio Code. This is our new project. You can see various files and folders in the Explorer panel on the left. But we'll look at those later. First, let's see how to run this app. If we go and open a new terminal, and I'll use the integrated one, we can start the app using the Ionic command line tool by running the serve command. And this will start a development server, just like the one we used in our previous examples. The only difference is that using the Ionic CLI, the server runs on port 8100. But apart from that, it's exactly the same dev server used by Create React App. So here in the browser, we can see our initial app based on the blank template. It has a toolbar with a title and some simple content with a link to the Ionic documentation. Pretty simple. In the next video, we'll look at this project in more details. But for now, we created a new project using the Ionic CLI, and we got it up and running using the Ionic serve command. We created a new project using the Ionic CLI, and we're running it locally with the Ionic serve command. Now let's have a look at the structure of this project. If we start from the package.json file, here we can see all the dependencies that have already been installed. Since it's an Ionic React project, of course we have the React packages and the Ionic React one. We already have Ionicons as well. These are all packages we used in our first examples. However, there are some other dependencies we haven't used yet, like React Router and Ionic React Router. We'll talk about routing in more details in the next section. This project is also using React scripts. This is the same package used by projects generated with Create React App. It's the command used when starting the dev server, building the project, and so on. So a project created with the Ionic CLI is pretty similar to one initialized with Create React App. However, unlike our previous examples, this project uses TypeScript. If you haven't used TypeScript before, TypeScript is like JavaScript, but with some additional features. We'll talk more about TypeScript later. Moving on, we also have Capacitor Core because we enabled Capacitor when creating the project. And if we scroll down a little bit, under Dev Dependencies, there's also the Capacitor CLI, that is the Capacitor command line tool. The order in this package.json file is a bit strange, probably because it's auto-generated. I'll show you later on how I like to tidy things up a little bit. Anyway, these are all the dependencies. We already have all the Ionic and Capacitor packages we used earlier in the course, and a few more that we'll look at in the following sections. In addition to package.json, there is a capacitor.config.json. So this is the capacitor configuration file that we've seen before. If we want to build this app for Android and iOS, then we need to make sure to change this app ID and put our own identifier using the reverse domain notation, something like org.example.myapp if you own the example.org domain. Likewise, you may want to change the app name because this is what is displayed to the user, for example, in the app launcher. So we could write my app but in title case instead of just displaying the folder name. It's important to configure these settings before generating your Android and iOS projects with Capacitor. That's why I recommend doing this right after creating a new project with the Ionic CLI. Now let's go and look at the application code. There is a public folder that contains an index.html file, just like any project generated with Create React App. But in this case, there are a few extra things specific to Ionic. For example, it's configuring the viewport, like we did at the end of the last section, to make sure the page looks fine in mobile browsers, especially Safari for iOS. So that's already taken care of. Now, in the body of the HTML, there is a div element with ID root, which is where our React app will be dynamically inserted. Again, this is no different from any other React project. Now, let's look at the source folder. Here we can see that instead of JS files, we have files ending in TS or TSX. These are TypeScript files. The normal extension for TypeScript is TS, but it must be TSX if it also uses JSX, which is what we use for writing React elements, of course. Now, if we open this index.tsx, you can see that it looks very much like a regular JavaScript file. There are actually no TypeScript-specific features in this particular file. All it does is rendering the app component into the document element with ID root. Once again, nothing new here. Let's look at the app component now, that is in this app.tsx file. Here you can immediately see that there are a lot of CSS imports. In fact, it's importing all the Ionic CSS files that we manually added in our first example. So that's already done for us in this project. In addition to the Ionic style sheets, it's also importing a local variables.css file that's under the theme folder. If we go and look at that file under theme, you can see that it contains all the CSS variables we can use if we want to customize the Ionic theme, something we've done earlier in the course. But in this project, we already have this file, and we just need to change the values if we want. Now, this app.tsx is mostly like a normal JavaScript file, except for this small bit here where it declares that app is a variable of type React-FC, where FC stands for function component. This is called a type annotation, but again, we'll talk more about TypeScript later in this section. Now, if we focus on the JSX elements, you can see the familiar Ion app component at the top. But then there are a number of components we haven't seen before, like Ion React Router. A router is required when you have more than one page in your app. We'll cover this in great detail in the next section. All you need to know for now is that at the end of the day, this code simply renders this home component. And I can prove that to you by replacing all this stuff with the home component directly. Let me show the browser again so we can see the result in the page. If we save these changes, you can see that the app looks exactly the same as before. There will be just a few warnings in the console because of unused imports. If we look at the top of this file, we should remove all these components we're not using anymore. But this was just to show you that all this code does is basically just display the home component. Let's keep the original code anyway. So what's in the home component? You can see that it's imported from pages/home. Let's go and look at this pages folder then. Here we can find home.tsx, and this code should look more familiar. There's an Ion header, an Ion content, and other elements we've seen before. There's also an Ion page at the top that has to do with routing. So again, we'll cover it when we get to the section on page navigation. Obviously, we can edit this file and, for example, change the title to My App. And if we save the change, the page will automatically update, showing the new title. Now, in the content, it's displaying an Explore container. This is just a local component imported from the Components folder. Let's look at that folder quickly. Here we have Explore container.tsx, and this is a React component that renders the content you see in the page. Incidentally, this initial code generated by the Ionic CLI tends to change from time to time. So if you're seeing some slightly different code on your machine, that's probably just because the Ionic team made some changes to the blank template. But this is just an example of defining a custom React component. There's another TypeScript feature here called an interface that I'll explain in one of the next videos. I guess what they're showing here is how you can style a component simply by importing a CSS file named like the component itself. This is just what we did in our biorhythm calculator example. Like I said, this is just sample code anyway. As you start writing your own functionality, you're probably going to delete that Explore container component. What matters is the main structure of the project. The fact that it already imports all the necessary Ionic styles, theme variables, it provides an app component that uses Ion app, and so on. So this is the initial structure of a project generated with the Ionic CLI. In the next video, I'll tell you about a few changes I always like to make to this generated code. We had a look at the code of this project as created by the Ionic CLI. Now I want to tweak this generated code a little bit. Let's start from the package.json file. But before we make some changes, I'm going to stop the dev server that was still running. So the sections in this package.json are in a pretty random order. Typically you have the scripts at the top before the dependencies. So let's move this block up and put it here. This way it's easier to see which npm scripts you can run in this project. Also, if we scroll to the bottom, we have dev dependencies here that logically should be after the normal dependencies. So let's move them here. Now, it's a bit strange to have a single dev dependency. There are other packages that are only used for building the project, like React scripts and TypeScript. So let's move those to dev dependencies as well. And fix the commas. What's next? There are some testing library packages that are only used for automated tests. And there are also all these types packages. These are used by TypeScript to handle libraries that are written in regular JavaScript, like React. Either way, we can consider them dev dependencies. This is just a conceptual distinction, really. But this way, it's easier to see which ones are the main libraries we use in our project, like Capacitor Core, Ionic React, and so on, and which packages are only used for building and testing. That are those under dev dependencies. Okay, so that's cleaner, I think. Now we can tweak these scripts a little bit. The eject command is something you never use in practice, so we might as well remove it. More importantly, we've seen that to start our app for local development, we use the Ionic serve command. So let's write it here, and then we can simply run npm start, like in most projects, and this will execute the right Ionic command. Similarly, for the build phase, we haven't seen this yet, but the Ionic tool provides a build command. So if you do npm run build, this should launch Ionic build. The test script can stay as it is. There is no special Ionic test command. Now, we installed the Ionic CLI as a global package on our machine. But if we're using it for this project, it would really be better to install it as a dependency of this project. So if somebody checks out our project code, they'll just need to run npm install to get everything they need to work on this project without having to separately install some other package globally. So let's go and add the Ionic CLI package. Before we do that though, since we modified the package.json file, I'm going to remove the package lock.json and then run npm install again. This is to make sure that what's installed matches what we have in package.json. Okay, now we can install the Ionic CLI by running npm install at ionic/CLI, and we want to save it as a dev dependency. Also, let's save the exact version, just in case there are some incompatibilities between different versions. Okay, the Ionic CLI should now be installed as a dev dependency of this project. And we can now start our application again, but this time we can simply run npm start because we changed the script in package.json to take care of launching Ionic serve. Okay, this opens a new browser tab that we don't really need because we already had the app running here. But the dev server started successfully. What else did I want to do here? Let's open app.tsx. Here we have all these CSS imports that I find a bit annoying whenever I need to change some code in this app component. So I usually move them into index.tsx instead. It's the same thing because the styles will still be applied to the entire application. But index.tsx is not something you need to modify very often. So I prefer to put all the CSS stuff here, which means that there's a lot less noise in the app component code. If we look at the page in the browser, this change should make no difference. This is just my preference. You can keep the stalls here if you want, of course. Now, if we go back to index.tsx, there's another thing I always do right after creating a new project, and that's hiding the splash screen. If you remember, we've seen how to do that in the previous section. We need to import the plugins object from the capacitor core package. And then we can use this plugins object to extract the splash screen instance. And right after rendering the React app, we should call splash screen hide. So this makes sure that we don't show the splash screen for any longer than we need to. I recommend making this change at the beginning if you plan to build your app for Android and iOS, just so you don't forget. Okay, so that's the splash screen sorted. Now, if you do want to use capacitor, also remember to configure the right app ID in capacitor.config.json. But we already did this in the previous video anyway. So I think that's it. These are just some changes I recommend making to the code generated by the Ionic CLI, and especially the package.json file. As we've seen, the Ionic CLI generates a project that uses TypeScript code. It's obviously possible to use Ionic with plain JavaScript as well. That's what we did in our first examples, after all. But there isn't currently an option to tell the Ionic CLI not to use TypeScript when creating a new project. And there are some advantages in using TypeScript compared to plain JavaScript. So in this video, I'll give you like a 10-minute introduction to TypeScript for those of you who have never used it before. If you are already familiar with TypeScript, feel free to skip the rest of this video. So let's open our home component. That's what we see on the page. This file is almost entirely the same as a regular JavaScript file. The only TypeScript-specific feature is this type annotation that says that home is a React function component. But we'll see what a type annotation is in a minute. Let's start by removing everything from the content, so we can get rid of this import as well. And maybe let's add the ion padding class to this element, so we get some spacing around the content. Now, let's suppose that our app provides our users with an account where they can keep some money. So in this home page, we want to display the balance available to this user. And this balance will be a value that we get from somewhere, like from a backend API. But for this example, let's just hard-code a value here, say 123. And then in the content, we'll simply display the value of this variable. Now, if we save, we'll see your balance is 123. Nothing fancy so far. However, since 123 is a sum of money, we probably want to format this number appropriately. So we could write a function called formatMoney that takes the amount as a parameter and returns a string starting with a $sign, assuming this account only supports US dollars for now. And then we can concatenate the amount, but always displaying 2 decimal places, as is typical for dollar amounts. Now, this is just an example, of course. There are better ways to format currencies, but let's focus on the language features. You can see that the editor highlights an error here. It says that the parameter amount implicitly has any type. We'll see exactly what that means later. But in the project, there is a file called tsconfig.json. This is a configuration file used by TypeScript. You normally don't need to worry about this file, but there is an option here called strict, and it's currently set to true. If we change this to false, we can basically tell TypeScript not to be so strict with its checks. And if we save this change and go back to home.tsx, you can see that the error has gone away. Like I said, I'll give you a more detailed explanation later, but setting strict to false basically allows us to write regular JavaScript code without TypeScript complaining. So now we can use this function to format our balance. And if we save, we can see the value properly formatted as a dollar amount. So this is how we would write such a function in plain JavaScript. One of the limitations of JavaScript is that there's nothing stopping somebody from passing a string instead of a number here. We could set the balance to bananas, and we get no warnings whatsoever that there's something wrong with our code. It's only if we run this code in the browser that we get an error. In other words, we only get an error at runtime, not at compile time. And the error we get is not particularly clear either. It says amount to fixed is not a function. So we need to look at our code and think, why is toFixed not a function? Oh, that must be because amount is not a number. It would be easier if the error message just said, when calling the formatMoney function, you passed a string instead of a number. That would be so much nicer, right? Well, that's one of the things where TypeScript is better than JavaScript. With TypeScript, we can declare that amount should be a number. So the syntax is after the variable name, we write colon and the type. And this is called a type annotation. With this simple change, the editor now immediately shows us an error when we call formatMoney, politely telling us that we cannot pass the literal string bananas because the argument must be of type number. So we know exactly what we did wrong, and we can go and fix it by setting this to a number. And this should fix our application. Now, of course, this was a silly example. But imagine that you write a function in one file, and then sometime later somebody else tries to use your function, importing it into some other file. They could easily pass the wrong argument type by mistake. So that's one thing TypeScript helps with. And declaring the type also has another advantage. It helps the editor provide suggestions when we type. Since the editor now knows that amount is a number, it can show us all the methods we can call on a number. Visual Studio Code is using the TypeScript compiler to help us write our code. In addition to declaring the type of a parameter, we can also specify the return type of a function. In this case, we return a string. And by writing this type annotation, we also make it easier for somebody reading this code to immediately see what type of value is returned by this function. Now, even if we don't specify the types, the TypeScript compiler can still help us in some cases. TypeScript does something called type inference, which basically means that the compiler will try to automatically detect the type of each variable based on the rest of our code. For example, if we inspect this function, you can see that the compiler automatically figured out that this function returns a string. How does TypeScript know that? Well, after the return keyword, there is a literal string, followed by the plus sign, which in this context means string concatenation. So this expression can only possibly result in a string. However, if we look at the amount parameter, TypeScript here detects that it has type any. Any is a special type, which means that this variable can be anything, basically. It's a bit like saying we don't really know the type of this variable. And that's because the amount is passed in as an argument to this function. So we cannot really know what type this will be, because it depends on some other code elsewhere where this function is called. So in these cases, TypeScript uses this special type called any. And in fact, if you remember, any was mentioned in the error we got initially when we had strict set to true in tsconfig.json. If we enable the strict option again, we can have another look at that error now. It says parameter amount implicitly has an any type. So with strict enabled, TypeScript refuses to accept code if it cannot automatically determine a specific type and has to default to any. But note that the error said implicitly. We can still decide to explicitly set the type to any. And in this case, there are no errors, even with strict enabled. So we are allowed to use any as a type in our annotations. And this can be used as a quick and dirty way to avoid compiler errors. We are basically telling TypeScript, don't worry about checking the type of this variable. We'll take care of that in our code. We know what we're doing. But most of the time, if we write a type annotation, we want to use a specific type like number. Now let's go and disable the strict checks again, because I want to show you another TypeScript feature. Suppose that instead of only supporting US dollars, our app now supports multiple currencies. So instead of a number, our balance could be an object that has a currency property with a currency symbol like British pounds, and then the amount that can be the number we had before. This way, different users could have their balance in different currencies. In that case, we'll also need to change our format function, because we won't receive a simple amount number anymore, but an object that we can call money. And let's not specify the type for now. Then instead of amount, we can use money.amount, and instead of the dollar symbol, we want to prefix it with whatever the currency is for this object. So this is how we could write this function in plain JavaScript without types. And if we save this new implementation, we can see our balance in pound sterling. And if we change the currency to dollars, of course it will be formatted with a dollar sign. Now imagine that somebody is trying to use our function, but for some reason in their object they forget to include the currency. At this point, we see no compile time errors, and if we save, so the code runs in the browser, we see no runtime errors either. But we'll show the user a balance of undefined 123, which is of course pretty bad. In a sense, this case is even worse than our first example, because here we don't even get an error, we just display the wrong thing to the user. Anyway, let's see how we can improve the situation by using TypeScript. We want to declare the type for our money parameter, but what should that type be? Well, we expect it to be an object with currency and amount properties, but there is no predefined type for that. It's not like a simple number or string. So in these cases, we can effectively create our own custom type by defining an interface. We need to give it a name, like money, and then we can declare which properties it should have. For example, we want a currency property that is of type string, and another property called amount that is a number. So an interface is just a definition. It describes which properties an object should have in order to be considered a valid instance of, in this case, money. Now that we have this interface, we can declare this parameter as of type money. As soon as we do that, we can see an error when we call the formatMoney function. And the message says that the argument is not of the right type. In particular, property currency is missing. So we get quite clear instructions on what we should do to fix this problem. We need to add a currency property here. And with this, our app should be working again, working as displaying the right information. And again, by using types, we get the additional benefit of the editor providing auto-completion. It knows that a money instance has these properties, and if we select amount, for example, of course, it also knows that amount is a number, so these are the available methods. This does make our life as developers easier. By the way, we could re-add the return type here as well. Okay, so this was a very quick introduction to TypeScript. There are a ton of other features in the TypeScript language. In this video, I really just wanted to give you a taste of why you may want to use TypeScript. We will be using TypeScript to build our next application starting from the next section, but we'll keep the strict option disabled so we don't have to declare types everywhere. You should be able to follow along even if you're just a beginner with TypeScript. However, I do recommend taking a full course specifically on TypeScript if you want to learn the full power of this language, because we only just scratched the surface in this video.